this is part 2 of the 28-2 notes, so we're on number 5. Without a calculator, predict what the graph would look like. What do you think? You guys are smart. What's this going to do? That's going to reflect it over the line y equals x. So if I have my initial points, and I reflect that, it'll be here, here. And it will look like this. These points are here and here. Reflect that over the line y equals x. My graph will look like that. You can go ahead and grab your calculator if you want and see, and it will look like this, just the flip of the other graph. Number 6. Where are the horizontal and vertical asymptotes in these functions in relation to the asymptotes of the parent function? That's one too many t's there, ignore that. So, in the original parent function, the vertical asymptote is x equals 0. The horizontal asymptote is y equals 0. We've seen that in the parent function. What happens when I multiply by something? Well, it stretches or shrinks. That doesn't move it anywhere left to right, so these stay the same. If I multiply it by a number maybe less than 1, like a fifth, that just shrinks it. It doesn't change these, so I would say same asymptotes, same asymptotes. Did the asymptotes change here when I flipped it? No, they did not. You can go ahead and investigate that for yourself if you want. So number 6, there are no changes in the asymptotes if we're just vertical stretching or shrinking or reflecting, which leads us to number 7. Notice there's some adding going on here. That is when your vertical or horizontal asymptotes may change. Number 7, sketch the graphs of each function, describe the transformation of the parent function, state the vertical and horizontal asymptotes. Let's start with the parent function. So the parent function, do I want to draw the asymptotes? Sure, I will. So I have this. Maybe this is too messy. I'll just do the 4 points and the line as best I can. I should have done a dotted line, but I'll just use a different color. Alright, there's my parent function. Now there's no multiplication. We're adding 3. And notice it's close to the x, where over here it's away from x. It's not under the fraction. So this is going to be left and right. This separate is going to be up and down. Pretty typical with what we've learned before. And also this one's going to be up 3, while this one will be the opposite of what it looks like. It says plus 3, which normally we think to the right, but it's actually going to be to the left 3. So I take this parent function point, I go left 3. 1, 2, 3. Take this point, left 3. Same for these ones. Oh boy. There we go. Now, does it look like my asymptote stayed the same? Does it look like I have a vertical asymptote here at x equals 0? Now, everything shifted over 3. So my vertical asymptote is right here. So that vertical asymptote is going to be x equals negative 3, which you can kind of tell here we're moving everything to the left. Now, we did not move anything up or down, so the asymptote that was at y equals 0 is still at y equals 0. If you don't go up or down, that will stay the same. I'm really sorry it's messy. I hope that you are understanding. The red is the parent function, and the purple is the after function, the transformed function. You can go ahead and try B on your own if you want to pause it. I will go ahead and do the parent functions the same way in red. How am I getting these points? From the very beginning, plugging in these right here. Plugging in 1, 2, -1, and -2. Can't plug in 0 to the parent function. Ooh, that was a good one. All right, what is going to happen to the parent function? It's going to go up 3. Not left, right, not stretch, shrink. It's separately just being added off to the side. So the parent function points up 3. Same for these, go up 3. 1, 2, 3. 1, 2, 3. Ooh, that was nice too. All right, vertical asymptote. Let me draw a vertical line here. Where is the vertical line at? Well, it's touching the purple graph here. This is where it's not touching it. So, which makes sense because it's at 0. We cannot plug in a 0 here. So, x equals 0. That was not a change. Notice over here, it was -3. Because you can't plug in -3 there. -3 for x plus 3. That puts 0 in your denominator. Horizontal asymptote. What y value is not there? Looks like here, which is up 3. That makes sense because everything was shifted up 3. So a height of 3, y equals 3 is my horizontal asymptote. Please, please, in your homework, notes, quizzes, label vertical asymptote x equals 0. Don't just put 0. Don't put x equals 0. Vertical asymptote x equals 0. Horizontal asymptote y equals 3. They should be labeled in an equation. 8. Identify how the variables a, b, and c affect the graph of the parent function. All right, let's go in order. What happens first? Usually it's the left and right, so it's that b value. So b is going to move it left to right, opposite of what it looks like because of that negative. A is a vertical stretch or shrink. And then c is going to be up or down. Now a could be a fraction. It would just, you would kind of see it at in the denominator. You don't have to write all that if you don't want to. Number 9, describe each function as a transformation of the parent function. Identify x and y intercepts and asymptotes. So before we start, let's describe this. What's happening? This 3, vertical stretch by a factor of 3, up 1. Ooh, lots here. This is going to move it 1 to the left, reflect over x-axis, down 2. I think I'm going to do 1 point at a time here for this first one. So here's my parent function point. I'll do it in red because that's what I've been doing. Let's go in order. So I'm going to multiply this height by 3. 3 times 1 is 3. And then I'm going to go up 1. So 4, I'm going to do it all in 1. My other parent function point was a half. So I need to multiply that by 3. What's a half times 3? That would be 1.5. And then go up 1 to 2. Oh dear. Okay, then go ahead and let's do the same for the other one. Here's this point at -1, triple that height, -1, triple is -3, and then up 1 is actually going to move it back up here. Got to go up, not down. -1/2 times 3 is -1.5, and then up 1 is back here. So that's going to look. Let's start with vertical asymptotes. This is where it starts in the parent function. Did it move left to right? No. So vertical asymptote, x equals 0. Horizontal asymptote was originally here. Have I moved the graph up or down? Yes, I've moved it up 1. This is my new horizontal asymptote. Height of 1, y equals 1. Okay, so let's talk about x-intercepts and y-intercepts. We've done these before with other functions. We can look at the graph, sometimes know for sure, sometimes not. So here's a sure way to find the exact x and y intercepts. You should remember that I'm down here, an x-intercept, we set y equal to 0. And to find the y-intercept, we set x equal to 0. So pause the video, take this function, which we have here, and put in a 0 for y. See what you get for x. Over here, put in a 0 for x. See what you get for y. So here's my work. I took the function and I set y equal to 0. Put in a 0 there. Now let's think basic algebra. I got to find x. So subtract 1 on both sides. Now here, it might be helpful for some of you to turn this side into a fraction so we can cross multiply. So put that over 1. Cross multiply. Negative x equals 3. Divide by the negative, x is negative 3. Now I said you might be able to find this intercept in the graph without doing work. That's fine. Sometimes it's exact. You can do that. It's not always exact, so to find the exact value of the x-intercept, set y equal to 0. Now I'll go ahead and find the y-intercept by setting x equal to 0. Well, if I put a 0 in here for x, what happens? Can I take 3 divided by 0? No, so it's going to be none. Which makes sense because there was an asymptote there. So your x-intercept was negative 3, your y-intercept is none. Okay, go ahead and try B and then check your work. I'll go ahead and do one of the points with you so you have the order. So here's my parent function point. I'm going to go right 1, reflect over the x-axis, down 2. Okay, so now you plot the other 3 parent function points. Go left 1, reflect over x-axis, and down 2. Okay, I have my new points. You might say, well, I have no idea how to connect those. Maybe drawing the asymptotes next will be helpful. So look what happened. It went down 2, so I'm going to draw an asymptote that's down 2. That might help me graph it. Okay, that didn't work. And did it move left or right? Yeah, it moved 1 to the left, so I'm going to draw an asymptote 1 to the left. That should help you connect your points. Here's your 2 purple points, and you can kind of see that it's going to arch through there. Same here, I have 2 points. It's going to connect there. Go ahead and fill out those next parts.